Somewhere beyond the orbit of Jupiter, something is leaving our solar system right now, and it did not come from here. It was never bound to our sun. It was never part of our story. And according to the very telescope NASA built to look back to the dawn of the universe, this object is carrying a chemical signature that shouldn't exist, one that suggests it is older than our solar system itself, possibly older than the sun, possibly older than Earth, possibly older than almost everything we have ever called home. NASA scientists have the data. The paper is published. And the more they read it, the less it looks like a comet, and the more it looks like a message written in ice, sent from a place and a time we cannot fully comprehend. Here is what most people are not seeing. On July 1st, 2025, a survey system built specifically to watch for dangerous objects hurtling toward Earth caught something, moving through our solar system that immediately broke the pattern. It wasn't orbiting the sun the way everything else does. It was passing through. A visitor, not a resident. Astronomers designated it 3I Atlas, the third confirmed interstellar object ever detected in human history. Only 2 others like it have ever been recorded, and both of them came and went so fast that we barely had time to point our instruments before they vanished back into deep space. This time was different. This time humanity had the James Webb Space Telescope waiting. But here's where it gets worse. 3I Atlas wasn't just passing through at a strange angle, it was moving in a way that almost nothing in our solar system moves. Its orbit is hyperbolic, meaning it is not gravitationally bound to the sun at all. It arrived from interstellar space, and it is leaving again, never to return. Its trajectory is tilted almost backward relative to the plane where our planets orbit, and it was traveling at roughly 57 kilometers per second relative to the sun, fast enough to cross the distance from New York to Los Angeles in under a minute. Read that again. This is not a rock that got flung out of some asteroid belt. This is a traveler that has been drifting through the galaxy for an unknown length of time, and Earth simply happened to be sitting in its path. For months, astronomers tracked it the way you'd track any comet, watching it brighten as it approached the sun, watching its icy surface begin to react to solar heat. And then, in December of 2025, as 3I Atlas made its closest approach and began speeding away from us forever, NASA made a decision that would end up producing one of the strangest scientific papers of the year. They turned the James Webb Space Telescope directly at it. Not for a quick look, not for a passing glance. They used Webb's most sensitive spectroscopic instruments, NIRSpec and MIRI, to break down the light coming off this object into its exact chemical fingerprint. What most people don't understand is that this wasn't about getting a prettier picture. It was about reading the object's DNA. And what they found didn't match anything in the solar system's chemical library. The coma, the glowing cloud of gas and dust released as the comet's ice warmed under sunlight, was dominated overwhelmingly by carbon dioxide, releasing far more CO2 relative to water than virtually any comet ever measured in our own solar system. The ratio was so extreme that researchers described it as sitting more than 4 standard deviations above the normal trend line for comets at that distance from the sun. In plain terms, if you lined up every comet ever properly studied and asked which one behaves the strangest, 3I Atlas would be standing alone at the edge of the graph, refusing to fit the curve everyone else follows. This is not chaos. This is a signature, and signatures tell stories. Here's where the story gets deeper, and this is the part that even seasoned researchers weren't expecting. Buried inside the spectral data, Webb detected something that shouldn't have shown up until much later. Methane seeping out from beneath the surface, not from the outer crust, but from deep, ancient layers that had likely stayed frozen and untouched for longer than our entire solar system has existed. Scientists believe this methane had been sealed under the comet's surface since its formation, only breaking free once solar heating finally reached down far enough to crack it loose. Think about what that means. This object carried something locked inside it, sealed away, protected from starlight and stellar radiation for an almost unthinkable stretch of time. And it took our sun's heat, billions of years after that ice first formed, to finally let it out. But the detail that actually stopped researchers in their tracks wasn't the carbon dioxide, and it wasn't the methane. It was deuterium, heavy hydrogen, an isotope that acts almost like a cosmic timestamp. When Webb's NIRSpec instrument analyzed the ratio of deuterium in 3I Atlas's coma, the levels came back nearly 30 times higher than what's typically found in solar system comets. According to the researchers who authored the study, published in the journal Nature on June 22, 2026, this points to one conclusion. 3I Atlas almost certainly formed in an environment that was extremely cold, extremely distant, and extremely old, a system that existed long before and far away from the one we call home. Let that sink in for a moment. This is not simply an object from another star system. According to the research team led by astrochemist Martin Cordner at NASA's Goddard Space Flight Center, this is very likely a relic, a frozen fragment from a planetary system that may predate our own sun. Not by a few million years, potentially by billions. While researchers have been careful not to assign it an exact age publicly beyond describing it as ancient and predating our sun and solar system, the implication is staggering on its own. Some of the material moving past your planet right now at 57 kilometers per second was assembled before the star that gives you daylight had even ignited. And this is where everything changes, because the story of 3I Atlas didn't stay confined to quiet academic circles. Once its extreme trajectory, its retrograde tilt, and its bizarre chemistry started circulating, at least one prominent physicist publicly floated a far more unsettling possibility that an object behaving this strangely might not be natural at all. The suggestion ignited public fascination and no small amount of panic across social media, with people asking the question every good thriller eventually asks, what if this isn't a rock? What most people missed, though, is that the answer to that question didn't come from speculation. It came from spectroscopy. The very same Webb data that made 3I Atlas seem so alien in its behavior was also the data that grounded it firmly back in natural explanation. A comet, yes, but one unlike any we had chemical evidence for before. NASA has been explicit on one point. 3I Atlas poses no threat to Earth. The mystery here was never about danger. It was about origin. But if you think that's where the unsettling part of this story ends, you're not seeing the full picture, because 3I Atlas turned out to be only the first thread in a much larger pattern Webb has been quietly pulling on since it began full operations. What most people are not seeing is that this telescope, built primarily to look at the earliest galaxies in the universe, has spent the last year returning results that are forcing scientists to question the very model used to explain how the cosmos assembled itself. And that story is, in its own way, even more disorienting than a single ancient comet drifting through our neighborhood. According to informed sources within the astrophysics community, the term circulating for this phenomenon is impossible galaxies. When Webb was first switched on, it was tasked with peering back to a period roughly 3 to 500 million years after the Big Bang, a cosmic infancy so early that, according to the standard model of cosmology, galaxies at that stage should have been small, faint, chaotic, barely formed smudges of light. Instead, Webb found galaxies that were large, structured, mature-looking, far more massive and organized than the standard framework, the same framework used to build essentially every cosmological model of the last several decades, said they had any right to be. Think about what that means for the scientists who spent their careers building that framework. It is one thing to discover a new object. It is another thing entirely to discover that the timeline of the universe itself doesn't add up the way we assumed it did. And this is where the tension escalates, because impossible galaxies isn't a fringe theory whispered by outsiders. It's a mainstream peer-reviewed puzzle that respected researchers are actively trying to solve without yet agreeing on the answer. Either galaxies formed and grew far faster than physics currently allows, or something about our understanding of the early universe's structure, its dark matter behavior, or its very expansion history needs to be rewritten. And just when astronomers thought they might be able to explain away the early galaxies as some kind of a statistical fluke, Webb delivered another discovery that deepened the crisis instead of resolving it. Researchers studying a distant ancient system called Abell 2744, QSO1, identified what they now describe as a likely direct collapse black hole, a supermassive black hole with a mass roughly 50 million times that of our Sun, sitting at the heart of a tiny, barely formed galaxy more than 13 billion light-years away. Here's the part that should make your skin crawl a little. The evidence suggests this black hole didn't form the way black holes are supposed to, from the collapse of a massive dying star, growing slowly over enormous stretches of time by feeding on gas and merging with others. It appears to predate its own host galaxy. It may have been immense from the very beginning, possibly forming within the first second after the Big Bang itself. Read that again. Not the first star, not the first galaxy, the first second. This is not an isolated anomaly anymore. And this is a pattern, and patterns are what turn a curious anecdote into a genuine scientific reckoning. Between the impossible early galaxies and the direct collapse black hole that seemingly skipped every step in the process we thought was mandatory, Webb has effectively handed cosmologists a puzzle where several of the pieces refuse to fit the box they were sold in. And every month that passes without a clean resolution, the pressure builds a little more, because somewhere out there is an explanation, and right now, nobody fully has it. If that were the entire story, it would already be enough to keep astrophysicists awake at night. But there's a third thread, and this one doesn't just challenge our model of the universe's structure, it challenges the deepest question humanity has ever asked. Are we alone? In 2025, researchers using Webb's instruments to study the atmosphere of a distant exoplanet called K2-18b detected the chemical signature of dimethyl sulfide, a compound that, on Earth, is produced almost exclusively by living organisms, largely marine phytoplankton. The announcement moved through the scientific world like a shockwave, and within hours it had reached headlines across the planet. Had we just found the first hint of alien life? But here's where the real story is more careful, more disciplined, and frankly, more suspenseful than the headlines let on. In science, a discovery isn't considered confirmed until it reaches what's called 5 sigma confidence, a threshold so strict that the odds of the result being a random fluke are less than 1 in a million. The dimethyl sulfide detection on K2-18b came in at roughly 3 sigma. Significant. Provocative. Absolutely worth investigating further, but not yet proof. Not yet a discovery humanity can stand behind and declare unequivocally that we are not alone in the universe. What most people are not seeing is that this uncertainty is not a failure. It's the system working exactly as it's supposed to, refusing to let excitement outrun evidence. And that's exactly what makes it so tense. Because right now, at this very moment, that question is sitting unresolved in observatories and research papers around the world. More observation time on K2-18b is being requested. More data is being gathered. Somewhere between now and the next major announcement, that 3 sigma signal could either fade into statistical noise, or it could climb toward the 5 sigma threshold that would make it one of the most consequential scientific findings in human history. Nobody currently knows which way it's going to go. And that uncertainty, that unbearable dangling not yet, is precisely the kind of tension that keeps entire research careers, and increasingly entire news cycles, locked in suspense. Now put all 3 threads together, because this is where the real story lives, not in any single discovery, but in the collision between them. An ancient interstellar comet carrying chemistry from a system that may predate our sun, galaxies in the early universe that grew faster and larger than our models say should be possible, a black hole that appears to have existed before its own galaxy, potentially forming in the first fractions of a second after the Big Bang, and a distant ocean world with a chemical signature that, if confirmed, would rewrite our understanding of life itself. Each of these, on its own, would be the biggest science story of a decade. Together, in the space of less than 2 years, they represent something else entirely. A telescope quietly dismantling the assumptions an entire generation of scientists built their careers on. What most people are not seeing is how connected these threads actually are beneath the surface. Every one of these discoveries points toward the same uncomfortable truth. Our models of time, formation, and origin in the universe are incomplete in ways we are only beginning to understand. The universe appears to have built structures, galaxies, black holes, planetary systems, faster, earlier, and stranger than the physics we trusted could explain. And now, an ancient visitor has drifted through our solar system carrying physical proof, in the form of frozen gas and heavy hydrogen, that material far older than our sun still exists, still travels, and occasionally still passes close enough for us to finally read its story. This is not chaos. This is not coincidence stacked on coincidence. According to researchers who have spent months poring over this data, it increasingly looks like a structural problem, evidence that something fundamental about our timeline of cosmic formation needs revision. And the institution sitting at the center of untangling all of it is NASA, working alongside the European Space Agency and the Canadian Space Agency, currently processing a volume of Webb data so dense that new anomalies are still surfacing in observations. Taken months, sometimes years ago, the telescope has been quietly rewriting textbooks in near real time, and the public conversation is only just beginning to catch up to what's already sitting in the archives. So where does this leave us? The Roy Atlas is already gone, hurtling back out into interstellar space, never to return, carrying its ancient secrets with it. But the data it left behind is still being analyzed, and researchers have made clear this will not be the last interstellar visitor humanity detects. Survey systems built to catch dangerous asteroids are getting better every year at catching objects like this one, meaning the next interstellar traveler may not slip through with only weeks of observation time. It may be spotted earlier, tracked longer, and studied more deeply than anything we've managed so far. What will it be carrying? What will its chemistry reveal? Will it, too, turn out to be older than our own sun? Meanwhile, the fight over the impossible galaxies is far from settled, and every new deep field observation from Webb risks adding more evidence to a crisis that cosmologists have not yet found a clean way to resolve. And somewhere in a distant patch of sky, K2-18b continues to orbit its star, its atmosphere either quietly holding the first real chemical evidence of life beyond Earth, or holding a statistical illusion that will fade the moment enough data accumulates to rule it out. Nobody currently knows which outcome we're heading toward. Telescopes are already scheduled to look again. What we do know is this. The James Webb Space Telescope was built to look backward in time, to the very edges of the observable universe. And in doing so, it has ended up handing us questions about our own solar system's history, our galaxy's formation, and the possibility of life elsewhere that none of us are fully equipped to answer yet. Somewhere between an ancient comet older than the sun, a black hole that may have existed before its own galaxy, and an ocean world that might, or might not, be alive. There's a version of the truth waiting to be confirmed. NASA has the data, the papers are being written, and whatever comes next, it is unlikely to make the universe feel smaller, or safer, or more familiar than it already has stopped being.